So we want to find the equation of the tangent line to the curve, this guy right here, at 1, 2. Okay. So this guy right here, if we went ahead and we graphed it out, what I'm going to do is grab Desmos here. Just to take a look at what we're dealing with. So this will be 2x to the 6th plus y to the 4th equals 9xy. Okay, so got this little propeller looking thing here. I'm going to zoom in. And now what they want is at 1 over 2 up, which is, let's see if I can get on that curve, just this guy right here. Okay, if I zoom in a little bit more, so 1 over 2 up right there. I want the tangent line. Okay, so let's go ahead and do that computation. So what I'm going to need to do is I'm going to find dy dx at 1, 2. So let's take our curve over here. And now we've got to differentiate this. Okay, so we'll take the derivative with respect to x, dy dx, or ddx, excuse me, of both sides and of every term here. So that'll be the following. Okay, so the derivative with respect to x of this guy, pretty easy to do. 6 times 2 is 12. X to the 5th plus. Now the derivative of this guy is going to be dy dx, this is the chain rule, times ddy of y to the 4th. And now the derivative of this, okay, this guy's a little bit more difficult because we have to use the product rule here. So let's pull the 9 out. Now we have to take the derivative of the first times the second plus the derivative of the second times the first. So that'll give us 12 times x to the 5th plus dy dx times 4y to the 3rd is equal to 9 times the quantity. This guy right here is 1. This guy right here, again, chain rule. So this would be 12x to the 5th plus 4y to the 3rd dy dx is equal to 9y. This right here is, this guy right here is 1. Okay, so it'd be plus 9x, 9 times x, times dy dx. Now we need to solve for dy dx, get that guy by itself, so we'll move everything onto one side that has dy dx, everything else onto the other side, just like you would solve for a variable. So we'll do it like this. We'll say 4y to the 3rd dy dx minus 9x dy dx is equal to 9y minus 12x to the 5th. So we'll factor out the dy dx on the left side. And then we'll divide through by this thing, so dy dx will be equal to 9y minus 12x to the fifth over 4y to the third minus 9x. Now what we need to do is we need to evaluate dy dx at the point 1, 2. So that'll be 9 times 2 minus 12 times 1 to the fifth over 4 times 2 to the third minus 9 times 1. So that'll be 18 minus 12 over, this is going to be 8 times 4 is 32 minus 9. So 18 minus 12 is 6. 32 minus 9 is going to be 23. And so now what we've got is 6 over 23 is the slope. 6/23 is the slope of this line right here. So if I want, I can check that using like Wolfram Alpha, or of course it's in the text. Now, if we go ahead, if I wanted to see that it actually touches there, what I could do is I could find the equation of the actual problem didn't ask for that. But let's say I want to find the y equals mx plus b, the equation of the tangent line. Okay, so let's say I want to find that guy. Well, I know the m value is 6/23. I know the point 21 is on the line, so 2 equals 6/23 times 1 plus b, which means that I've got 2 minus 6/23 is equal to b. This is 46 over 23 minus 6 over 23 is equal to b, and so that gives us 40 over 23 for the b value. So the equation is y is equal to 6/23 x plus 40/23. Okay, so let's go ahead and put that in there. Now watch, if we type that in, gotta rotate my computer, so give me a second here. So we had y is equal to 6/23 x plus 40. Oops, we don't want that guy down on the bottom. And there it is. And you can tell that these two guys both connect at 1, 2. Or they intersect there.